see here, I am first building the components of super heterodyne receiver. And you see here, I am going to add the elements. So first one, elements of 1 equal to RF, there's a function called RF element, which will be used to add the elements to your circuit. The name is TR switch. The gain is, see, it is actually loss, but you give the gain is minus 1.3. NF is noise figure. Noise figure, we take it as 2.3. And OAP3, which is 37. Okay, OAP3 is the third order intercept point. So these things you can get from any standard textbooks. Okay. And the next one, to model the RF band pass filter. So here you have a band pass filter. So you can create an RF filter object. You can give the center frequency and the bandwidth. You can also give the Z, the amplifier, and is the impedance of amplifier. You can create the RF filter object, that is element of 2. The same way, element of 3 is amplifier. Again, you give all the parameters. Element 4 is again amplifier, give all the parameters. And see, normal amplifier, you have to give gain amplifier. For LNA, you have to specifically give low noise amplifier as LNA as the specification. Okay, what type of amplifier it is. Then again, modulator. So this multiplier, right? So this is, it will work as both modulator and demodulator. Okay, so you are multiplying the signal with LO, correct? So I am giving modulator, command name, you give all the parameters and what is the frequency of the LO. So you see here, LO is your local oscillator, what frequency you are going to mix. Then you give the RF band pass filter, this band pass filter, then 2 amplifiers. So see here, I am giving again, once again, designing an RF band pass filter with the gain, center frequency, bandwidth, and everything I am designing, and two more amplifiers and so with this, I am creating an object superhet equal to RF budget of add all the elements, give the input frequency, give the available input power, and give the signal bandwidth. So this will create a super heterodyne object in MATLAB. See, the entire super heterodyne receiver is available as a block in MATLAB. So when you design all the elements using the command elements of I starts from 1. How much ever elements you have to create elements of I, and you have to use RF element of, RF filter of. Mostly we'll be using only these two. RF element, RF filter, amplifier means amplifier, modulator means modulator. Okay, so we'll be using only C. And when you see here, when you run this code, when you run this section, you can see the object getting created. Maybe I have to run the individual blocks. Then only I think it will be clear. I have to run the individual blocks because if I directly run, it will not consider. I am running each section, section 5. Section 5 is having some error. Seven. We have some error here. So it is saying too many arguments. So we have to see what is the error, and you can see here. So this is how the box set will look like. This is the final thing which you get in the Simulink, and you can measure the RF test bench. So you can measure this device using the Simulink. Everything will be available as a block here. Automatically, MATLAB will create this Simulink block structure for you, and you can verify the answer. You can vary the gain. You can set the input-output bandwidth, whatever values you have set, and if you click OK, it will evaluate the RF circuit under the different conditions, and it will show you the output. This code is available in two things. One is it is available as a MATLAB file, and it is available as a Simulink. You know what is Simulink? I know you know the basics of Simulink. Simulink is just like the In MATLAB, you need to write code for any application, right? But in Simulink, you have to drag and drop. And you can design applications in Simulink. That is the advantage. Okay. So super heterogeneous receiver we have seen. I'll be sharing all this code with you. We can have a look at how things are working.